We're now going to make a flip book of triangle congruence proofs, and we're going to do these proofs using the postulates that we just talked about on the other foldable. So the first thing I would do is I would trim all of the edges of every side of the paper as much as possible so we can get this pretty thin, so we can get it to fit in our notebooks. So I'm just trimming the edges of all the sides. Then I'm going to line it up to where hypotenuse leg is on the bottom. Angle side is right above it. And angle side angle right above that. Then I'm just going to fold these over to where they will all line up. And then I have my triangle congruence flip book. And we can just put a staple here, here, and there. Let's go ahead and pass that staple around and get that done. Okay, so the first proofs we're going to be doing are for the side, side, side triangle congruence postulate. So let's look at number 1. And let's go ahead and mark out what we're given. We know that side RP is congruent to side PS. And we know RQ is congruent to side QS. And we want to prove that triangle RPQ is congruent to triangle SPQ. So the first things we've got to do is write our givens. So we know that side RP is congruent to side PS, and that's given. Well, then we know that RQ, side RQ is congruent to side QS, and that's also given. So now if we're wanting to use side, side, side postulate, well, we're missing a side. So we've got to figure out if PQ is congruent. Well, is it? Yes, PQ is congruent to itself, and that's the reflexive property. So PQ is congruent to PQ, and our reason is the reflexive property. The side length is congruent to itself. I told y'all this would come in handy, so now you can believe me. Now we know that all 3 sides are congruent, so that must mean that these 2 triangles are congruent. So triangle RPQ is congruent to triangle SPQ, and that's by the side, side, side postulate. SSS for short. Okay, we're going to do something similar on number 2. We're going to try to prove that these 2 triangles are congruent. So we know that B is the midpoint of AC, and that AD is congruent to CD. So let's start with what we're given. So B is the midpoint of AC. And that reason is given. Well, if B is the midpoint of AC, then we know that AB is congruent to BC, because the definition of a midpoint says that it's in between, or in the exact middle of this line segment, making two congruent segments on each side. So we know AB is congruent to BC by definition of a midpoint. Well, now we can state our other given, and that's that AD is congruent to CD. That's given. So now we're going to do side, 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 so we're just missing this last side. Well, we know DB is congruent to DB. It's congruent to itself, and that's because of the reflexive property. So we can put that BD is congruent to BD by the reflexive property. Since we know that these three sides are congruent to these three sides, then we know that these two triangles are congruent. So triangle ABD is congruent to triangle CBD because of the side, side, side postulate. Now we can look at proofs using the side angle side postulate. So we're going to prove the two triangles are congruent by side angle side. So we have that XZ bisects angle WXY. And then we know WX is congruent to XY. So very first, we want to start out with our first given. So XZ bisects angle WXY. And that's our given. Well, what happens when our angle is bisected? Well, by definition of an angle bisector, it cuts the angle into two congruent angles. So I now have angle WXZ is congruent to angle YXZ. So angle WXZ is congruent to angle YXZ. And that's by definition of an angle bisector. Then we can state our other given, which is that WX is congruent to XY, and that's given. Well, we have one side, one angle, so now we need to prove this next angle, the one right at, the next side, the one right after that congruent angle is congruent. And we know it is because XZ is congruent to itself by the reflexive property. So XZ is congruent to XZ by the reflexive property. Since we have a side angle side in that order that are congruent, where the angle is between the two congruent sides, then we know that these two triangles are congruent by the side angle side postulate. So triangle WCX is congruent to triangle YZX by the side angle side postulate. Okay, Okay, we're going to use the same postulate for number 4. So it's given that N is the midpoint of LP and NO. And we want to prove that these two triangles are congruent. So let's start out with our given. M is the midpoint of LP and NO. And that's given. So now we've got to figure out, well, what does that do? Well, if M is the endpoint of LP, by definition of an endpoint, by definition of a midpoint, LM is congruent to MP. So we know that LM is congruent to MP by definition of midpoint. We can do the same thing for NO. Since M is the midpoint of NO, we know NM is congruent to MO by definition of a midpoint. That midpoint breaks it into two congruent pieces. So NM is congruent to MO by definition of a midpoint. Well, we're trying to do side angle side. So we have this side and this side. So that leaves it to where we've got to figure out if these two angles are congruent, because it's got to be the angle in between the two congruent sides. Well, lucky for us, these are vertical angles. And what do we know about vertical angles? They're congruent. So angle LMN is congruent to angle PMO because they are vertical angles. Notice I didn't label this angle M or this angle M. I had labeled it by the 3 endpoints, because if I were to call any of these angle M, I could be talking about any 4 of these angles. So we have to label it by all 3 of the endpoints. Now we have side angle side, so we know triangle LMN is congruent to triangle PMO by side angle side postulate. Now we can do proofs for angle side angle. So we're going to use the angle side angle postulate to prove two triangles congruent. So for number 5, it's given that PQ is parallel to RS and QR is parallel to PS. So let's go ahead and start there. Let's start with our givens. So we know PQ is parallel to RS and QR is parallel to PS, and both of those reasons are given. So now I've got to figure out, well, what can we do with that to move forward? We're trying to get at angle side angle, so we need an angle side angle to be congruent to another angle side angle. So if we have these two parallel lines cut by this transversal, then we know that angle RQS is congruent to angle PSQ by alternate interior angles. So angle RQS is congruent to angle PSQ, and that's by alternate interior angles. Well, we can do the same thing for these angles right here, right? So PQS is congruent to RSQ because they're also alternate interior angles. They're on alternate sides of the transversal inside the parallel lines. So angle PQS is congruent to angle RSQ. Again, because they're alternate interior angles. Well, we're trying to prove angle side angle congruent, so we have an angle and an angle, so we've got to get that side in between these two angles to be congruent, which is this side right here. Well, guess what? Side QS is congruent to itself, QS, because of the reflexive property. So QS is congruent to QS by the reflexive property. And we now have angle side angle congruence. So we know that triangle QPS is congruent to triangle SRQ by the angle side angle postulate. Let's look at number 6. We're again going to prove these two triangles are congruent by the angle side angle postulate. So we have C is the midpoint of AD. So by definition of a midpoint, AC is congruent to CD. And then we know AB is parallel to CE, and BC is parallel to ED. So let's start our proof with our first given. So C is the midpoint of AD. And that's given. Well, because of that, by definition, that midpoint cuts the segment into two congruent pieces. So we know AC is congruent to CD by definition of a midpoint. Now we can list our other two givens about the parallel lines. So AB is parallel to CE, and BC is parallel to ED. And those are both given. Well, if we look at parallel lines AB and CE, they're both cut by this transversal right here. So we could look at corresponding angles A and C. And to be more specific, angles BAC and ECD. Well, what do we know about those? They're corresponding angles. They're both above the transversal, below each parallel line. So corresponding angles are congruent. So we could say that angle BAC is congruent to angle ECD because they're corresponding angles. Now remember, we're trying to do the angle side angle postulate. So we have angle side. So now we've got to use this angle. Well, what do I know that this angle is congruent to? Well, I have this parallel line and this parallel line cut by this transversal. So hey, looky there. Angle CDE and ACB are corresponding angles. They're both to the left of the parallel lines above the transversal. So angle BCA is congruent to angle EDC because they're corresponding angles. Since we have angle, side, angle in that order all touching, we know that these two triangles are congruent by the angle, side, angle postulate. So triangle ABC is congruent to triangle CED by angle, side, angle. Okay, we're now going to prove two triangles congruent by the angle, angle, side postulate. So let's look at number 7. It's given that C is the midpoint of AE. So by definition, we would know AC is congruent to CE. And then we know AB is parallel to ED. So let's start our proof with our first given. C is the midpoint of AE. And that's given. Like I just said, by definition, then AC is congruent to CE. So AC is congruent to CE by definition of a midpoint. Then we can state our other given, that AB is parallel to ED. That's given. Now they gave us parallel lines for a reason, so let's look and see if we can find a transversal that cuts into these parallel lines. So we have parallel lines here and here, and looky there, there's a transversal cutting through it. So what do I know about angles BAC and DEC? Well, they're alternate interior angles, alternate sides of the transversal inside the parallel lines, so those are congruent. So angle BAC is congruent to angle DEC. That's because they're alternate interior angles. Now we're trying to prove it by angle, angle, side congruence. So if this is our side, this is our angle, it's got to be this angle over here, because it's got to go in that order: angle, angle, side. Can't be here, because that would be angle, side, angle, and we want to do angle, angle, side. So we have parallel lines AB and ED. Well, we have this transversal BD that can be cut through it. So angle ABC and angle EDC would be congruent because they're alternate interior angles. They're on the inside of the two parallel lines, and they're on alternate sides of the transversal. So angle ABC is congruent to angle EDC because they're alternate interior angles. So we have an angle, angle, side, angle, angle, side that are congruent. So these two triangles would be congruent. Triangle ABC is congruent to triangle EDC because of the angle, angle, side postulate. Now we can look at number 8 and try to prove these two triangles congruent by the angle, angle, side postulate. So we're given that TV bisects angle SVU. So by definition of the angle bisector, SVT would be congruent to UVT. Then we're given that angle TSV is congruent to angle TUV. So let's start out with our given. TV bisects angle SVU, and that's given. And because of that, by definition of an angle bisector, we know SVT is congruent to UVT. So angle SVT is congruent to angle UVT by definition of an angle bisector. Then we can state our other given, which is that angle TSV is congruent to angle TUV. And again, that's our given. And we're trying to do angle, angle, side. So we have angle, angle, side. Well, what do we know about TV? It's congruent to itself by the reflexive property. So TV is congruent to TV by the reflexive property. Well, guess what? We now have angle, angle, side, angle, angle, side. So these two triangles are indeed congruent. So triangle TSV is congruent to triangle TUV by the angle, angle, side postulate. We have just two more proofs left, and we're going to do those using the hypotenuse leg postulate. So remember, with hypotenuse leg, it has to be a right triangle. So this has to be a right triangle in order to use this. So let's look at number 9. It's given that triangle LKN and NML are right triangles. So we know they're right triangles. So perfect, we can use hypotenuse leg. Then we know that LK is congruent to NM. So let's go ahead and start our proof with the given. So triangle LKN and triangle NML are right triangles, and that's given. Well, we also know that side LK is congruent to side NM, and that's also given. Well, we kind of got to figure out if they're right triangles, where's the right angle? Well, it says triangle LKN is a right triangle and NML is a right triangle. So this middle letter tells us where those right angles are. So at K and M. And remember, we're trying to use the hypotenuse leg theorem, so that means that the hypotenuse and the leg of a triangle are congruent to the hypotenuse and leg of another triangle. Well, the hypotenuse is always opposite the right angle. So notice where it is for both of these. Line LN. Well, lucky for us, there's a property that says the segment can be congruent to itself. So LN is congruent to LN by the reflexive property. Well, we have hypotenuse leg congruent to the hypotenuse leg of the other triangle. So we know triangle LKN is congruent to triangle NML by the hypotenuse leg postulate. Let's go ahead and look at number 10, the last proof of our flip book. And we're going to use the hypotenuse leg postulate to prove that these two triangles are congruent. So it's given that triangle DEF and GHF are right triangles. So here we have our right angles. We have F is the midpoint of DG. So by definition of a midpoint, we would know DF and FG are congruent. And then we know DE and GH are congruent. So to start our proof, let's start with the first given. So triangle DEF and triangle GHF are right triangles. That's given. And we know F is the midpoint of DG. And that's also given. And like we just said, since F is the midpoint of DG, by definition of a midpoint, we know DF and FG are congruent because the midpoint cuts that segment into two congruent segments. So side DF is congruent to side FG by definition of a midpoint. Well, we have our last given we haven't used, so let's go ahead and put that. DE is congruent to GH. Well, guess what? We now have the hypotenuse and the other leg are congruent. So therefore, these two triangles are congruent. So triangle DEF is congruent to triangle GHF by the hypotenuse leg postulate. Oops, and I forgot to put my reason was given on the one before. So we've now just done 10 proofs in 30 minutes. Way to go. We can go ahead and glue this in to the next page in our notebooks, and we can title it Triangle Congruence Proofs.